Hello, welcome back to LIVENODING. In this episode, I want to try to recreate this kind of setup. So basically, it's like a ball that's moving linearly. If you watch like one of the balls, it's actually moving like in a sine wave pattern. So each one of them goes into the same center. They're never touching each other, but if our eyes looking at it, is actually like it's looking like a circular motion. So I recreated using geometry nodes. So in this example, I actually have 16 balls that seems to be like rotating, and I'll try to explain what's going on. Okay, so let me reduce this to 16. Let me show you how it works. So currently it's not doing the circular motions, but if I change this value and try to get some kind of equilibrium, eventually the 16 balls will kind of overlap, and it's becoming like this smaller circle rotating like a circle instead of like a spiral or other type of motions. Okay, so 16 balls become 8 overlapping balls. Okay, so that's the interesting part about this. So let's see the setup. First of all, let me turn off this offset translate. So we start with something like this. It's 16 balls, and I'm using the circular array from Johnny, and I have instance of UV sphere. Okay, I can control the size of the UV or the radius over here. Actually, I don't need this. Okay, so just simple 16 balls. If I use the translate instance, and let me turn this on. If I translate it in the X, you can see it's being offset. Okay, and I just need the X value. If I use a sine wave on the X, it's just gonna do this kind of undulating motions, a little bit like jellyfish. But we're gonna do some kind of offset and also sine wave. We still have the sine wave, and we're gonna offset it using the index. Okay, so let me show you. So currently it's already doing that circular motion again. I can reduce this to different number. I can have 12. 12, that means our balls will be 6. Okay, 6 balls. I can change the radius, and it's gonna do the ball rotations. Okay, so it's pretty weird. Let me try to explain it. Okay, so basically we arrange the balls like this. Okay, each of the ball motions need to be offsetted, so it's moving linearly using like a sine wave pattern. So it's gonna move just like in a straight lines. This one also is gonna move in the straight lines. This one also. But if we offset all the motions, eventually we're gonna get like a circular motions, and it's kind of like reaching equilibrium or something, and it start to move in this kind of circular pattern, kind of like a ball bearing or something. Okay, so that's possible. First of all, okay, there's the sine wave. Okay, that one is important, and then we need to offset the balls. So it's the sine wave, it's instead of being between -1 and 1, it needs to be offset based on this the radius of the original circular value. Anyway, that's slightly complex to explain. And then the sine wave is being offset based on the index. What's the value? It's something that's I think there's some math behind it, but for now we just use the, you know, just eyeball it. I'm holding shift and then just playing around with this value until we reach that kind of equilibrium. Okay, so if I have like 32 balls at the moment, it's kind of chaotic. I have this time that goes inside, and then with the added offset from the index, this gonna control the speed. This one is gonna control the offset of each index, and I'm gonna try to find the one that's giving the circular motions. Okay, we might be close. Okay, this is the result. Okay, we get this kind of result once again. So again, I keep saying there are actually 32 balls, 16 of them kind of overlapping. Maybe I think this works because this kind of motion happens because we have like a sine, and then we have the offset of the sine based on the index. At that point, it's becoming like cosine, so it's becoming like circular motions. But two balls is actually overlapping on top of each other. So if we have like Suzanne, for example, instead of UV sphere, if we plug this as the offset, and we transform this, scale this, you can see there are two Suzanne in the opposite directions, right? So they are overlapping, and you can actually get rid of one of the Suzanne head and then try to bake it and recreate, just create it as AR like this. It's really unusual pattern. It's almost like dancing, but yeah, this proved the points anyway. So you can pick a number again, for example 18. With 18 again, the value changes. So I'm gonna try, I need to find the one where Suzanne is overlapping, and now we have the circular pattern again. We can have some interesting result if we just play around with the value and see if we actually, if we turn off the subtract, for example, and we get this offset, we get this kind of motion like a star, or like a flower type of motions. So this is without the offset. We can already see that at some point it creates like a nice flower motions. If we subtract it and normalize the value, we can have the overlapping circle. There. Whenever Suzanne kind of overlapping on top of each other, it's gonna be circular. So we can increase this. I think it's possible to make it looping. This is one. It's gonna loop maybe 51 or 50. Okay. Yeah, there must be like math behind it, but for now I'm just gonna use my eyeballs. Okay, if we have 64 Suzanne, see it's doing like a flower pattern, and then we adjust the value. This is like multiplier. Okay, this is cool. At the moment it's like a spiral centipede. each one of them is doing sine wave. Now I'm gonna offset it and multiply it until they are overlapping, and it's gonna do the circular pattern again. Let me use the sphere once again. Okay, there at the moment, yeah, it's becoming like a, you know, if you look at it properly, it's also like if you're using like a hula hoop, it's the same thing. So the ball is moving in the linear pattern, but because they are being offset in a certain value, we get these circular motions of them together. But if you play around with this value, for example, you're gonna get quite an interesting result as well, like flower. So 3 flowers, 6, and then it's almost like a juggling pattern. It's quite fun to look at this for a while, and you keep moving this value until we reach some kind of harmony. Okay. Even like, okay, this 3 circle rotating is quite interesting. And you keep offsetting and offsetting until you get that value where it's just like circular motions. It's pretty weird. Let me try increasing this 100. As the value get more and more, you're gonna start to see like a circle. You can have circle inside another circle. It's pretty weird. Maybe let me slow this down. Okay, like this. Okay, it's really weird. We have 4 circles entangled. If it's 5, it's gonna be like the Olympic. Okay, this one we have kind of like a 2. Gonna try to find the circular one. 5. Okay, we have 5, 3. I probably missed the value. Okay, let me try from 0 and just move this until it's kind of overlapping. There's the circular motion. And let me reduce the size of the circle. Okay, once again we have the balls in their linear motions, but together it's becoming like circular. Okay, all right, so that's basically the setup. You can just simply copy these nodes and you're gonna get the same result. And if you ever want to bake it, file, export, use Alembic, and you need to play around with this. Yeah, use instancing or actually turn it off, and yeah, that's gonna bake it and you can turn it into AR. All right, so thanks again for tuning in, and I'll see you next time. Thank you.